No, the problem is the space is.
Any questions? Okay.
But
All right.
actually,
Oh,
I have
yeah.
one question.
Caleb.
For like the online vector lab,
Yes.
when it's asking us to add them, and it says like A plus B equals R1, and then like it gives us like 5 different things to do.
Right.
Does it mean it wants us to do A and B and then see what R1 is, or R1 needs to equal A plus B?
What is expected? I guess it gives you a grid pattern. And I don't remember what A and B are explicitly, but for the sake of this example, we'll just say that this is A. And B. So if you've got R1 is equal to A plus B, then what I'm sort of expecting is that in the grid, off to the right, you'll start with either A or B, it doesn't matter which one. You start at some point. A, you go 2 over and 1 up in my example. So 2 over 1 up, so A. B, you're going 2 left and 2 up. So now here, so I go 2 left and 2 up. So that's B. So R1 is the sum of them. So we're adding head to tail. So the sum. So it'll something like that.
Okay. So shouldn't it be exactly what they like add up to, but around? Like if we.
Well, I think you're only using integers, so it should come out pretty close.
Okay. Because I was using like the Pythagorean theorem form.
Oh, no, you're not expecting to, you're just drawing it.
Okay. That's what I thought it wanted us to do. So.
Yeah, just drawing. Other questions? All right, so we spent the last couple of classes talking about position, velocity, acceleration, and so forth. And, you know, I just sensed that all of you were thinking, there's not enough math. We need more math. And some of you are shaking your heads no, and I'm assuming that you're just kidding around. Let's get into some math. Let's get into more of what this stuff actually means in terms of predicting the future. Somewhere there's going to be a marker that it's dark enough in a car. Starts at 30 meters per second and travels with a uniform acceleration of negative 6 meters per second squared for 10 seconds. So that's sort of the setup. What is the final velocity? Starts at, we'll put a plus sign right there. Final velocity. Bless you. What is the average velocity. What is the distance traveled? What is the average speed?
Did I say -6 meters per second squared?
Negative 6 meters per second squared. All right, any other questions on my handwriting? All right, so let's start looking at this piece by piece. The reason I put a plus sign in front of the 30 meters per second is I wanted to indicate that that is the initial velocity, not just an initial speed. The fact that I put the plus there is indicating it's traveling in the positive direction, so that gives us a direction. I guess one other thing I really should put into this is that it travels in a straight line. Probably along a straight line. So we're not dealing with any turn. We're not dealing with any curves. It will turn around, but it will stop first before it turns around. There are at least 6 problems I have on Blackboard with detailed solutions that are all basically this type problem. All right, so in essence, there are just 5 vector quantities that we really need to know here. So there is displacement, initial velocity, final velocity, acceleration, and time. Those are the main ones that we would need for any constant acceleration problems. If I know 3 of those things, I can find the other 2. So let's start piece by piece. Now there are shortcuts depending upon your math sophistication. I'm not necessarily going to do the shortcuts, or if I do a shortcut, it will be just a quick aside. I do a video where I talk about how to find the displacement differently than what I'm about to do here. And based upon the first tests in the past, some people latch on to doing it that way and some people don't. All right, so final velocity. I know the acceleration is -6 meters per second squared, and it's going to travel for 10 seconds. So at time 0, let's see, this is time in seconds. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All right. So I have time, and I want to know my final velocity. So my velocity in meters per second, and it starts out at 30. Acceleration is how the velocity changes. That -6 meters per second squared, I can rewrite that as my acceleration is -6 meters per second squared, which is -6 meters per second. This tells me that my velocity changes by -6 meters per second every single second, as long as it is uniform, which is the same thing as constant. Uniform acceleration, constant acceleration, same thing. So if my velocity changes by negative 6 meters per second each second, what is my velocity after 1 second?
24.
Keep going.
18. 12. 6. 0. Negative 6. Negative 12. Negative 18. Negative 24. Negative 30.
All right. So what is my final velocity?
Wouldn't it be, wait, 0 if it, because it comes back all the way that it went? Or no?
All right. That would be the way you would approach it for average velocity.
Okay.
But for the, when I just say what is the final velocity, that is the velocity at the end of the problem.
Okay.
So somebody, I think somebody said it.
Negative 30.
Give me the whole thing.
Negative 30 meters per second.
Yep, there we go. So negative 30 meters per second. Wait a minute. Okay, question is how we got the negative 30 meters per second. Is that an indication of a question, Chrisland? Is that, yes? Okay. What the acceleration tells us is how the velocity changes. And the number, the negative 6, tells me what happens every second. So basically, we just subtracted 6 every second. That's how we got, and then you just keep going until you get to there. A potential shortcut is I know that acceleration is negative 6 meters per second squared, is the change in velocity over the change in time. Again, that capital delta just means change. So I know that negative 6 is equal to my change in velocity over 10, because the time elapsed was 10 seconds. So got two fractions equal to each other. I multiply the diagonal I know, and that's equal to the other diagonal. So my velocity is going to change negative 60 meters per second. If I start at 30 and it changes by negative 60, I end up at negative 30. All right, so average velocity. What is my average here?
0.
How'd you get that?
Because it was 30 meters per second at one point and negative 30 meters per second at the end point. And then if you add those two together, it's 0.
How do you normally average? If I gave you a set of numbers and said average them, would you just take the first and the last one and?
If I did all of them, then I would just add them all together and then divide by how many there are. So I'd add like all the numbers together and divide by 11.
Okay, and that's an important thing there. You're dividing by 11, not 10. Most common mistake here is people divide by the time and not by the number of numbers. So if you add them all up, you do get 0. So my average velocity is 0 meters per second. And if on average I'm going 0 meters per second, what's my displacement after 10 seconds?
0 meters.
Yeah. Back where I started. My original intent was not to have zeros there. We'll change it for the next problem so that we're not dealing with zeros. Distance traveled. Well, I know I've traveled more than 0 meters. This is just telling me I am 0 meters from where I started. So this just tells me I'm back at my starting point. And my average velocity is 0 because I'm back at my starting point. For those who haven't gotten that part on the lab, there's a clue there. So the distance traveled, well, I went somewhere in the positive direction. I slowed down as I went, but if I assume that positive direction is this way, I have a starting point here, I travel a certain distance, I'm slowing down, and then I turn around and I come back and I end up back up here. So the distance traveled is how far that way plus how far this way. We're dealing with scalars here, there's no negative distance. So the question is, how far do I travel to here? Well, how much time does it take for me to get to there? And what's the clue that it's 5 seconds? There's, I guess, 2 approaches here. Why is it 5 seconds?
Because that's when you get 0.
And the other way? That's the most useful way, by the way.
It's halfway.
Yeah, in this particular case, halfway works. In general, we're not gonna end up back at the starting point, so where the velocity is 0 is the turnaround point. All right, so that's 5 seconds. I'm going 30 meters per second here, and I'm going 0 meters per second here. So I'm looking at just this first range. I'm looking at this section right here. What is my average velocity for those first 5 seconds? Just pull out a calculator or use paper and pencil. I got 6 velocities here. What's the average?
Probably 15, right?
Did you do it out on the calculator or you're just jumping ahead?
Yes.
18. 90 divided by 5.
How many numbers did you add together?
Oh, it's 6.
15,
Sorry?
15, and you divide it by 6 numbers.
Yeah,
Well,
you divide by
yeah.
6. So what was the sum?
90.
90. All right, so you add them all up, you get 90. 90 divided by 6 is 15. But what's so special about every second? Suppose I looked at every, I'm gonna change that around. You know what, we'll stick with 15, I'll go into that routine later. So my average is 15 meters per second. So on average, I'm traveling 15 meters per second for that first 5 seconds. How far did I go? Or how would you figure it out? Or think, if I'm driving in a car and I'm going on average 50 miles per hour for 3 hours, how far did I go?
75 meters.
Okay, you're answering the other question. Yes, it's 75 meters. How'd you get that?
15 times 5.
Yes. So if I'm going on average 15 meters per second for 5 seconds, that means that every second that passes, I go another 15 meters. So you can add 15 up 5 times or multiply, and you get 75 meters. So that's how far I travel in the first 5 seconds. How far do I travel in the second 5 seconds?
75,
So what is the total distance traveled?
150 meters.
Somebody just said it?
150 meters.
Yes. And what is the average speed?
Fifteen. 15?
Is 50 units?
15 meters per second.
Yep. Average speed is the distance divided by time. Average velocity is displacement divided by time. So this is 15 meters per second. Questions up to here? All right, let's do one with less symmetry. Let's change. We'll use the magic of an eraser. And make that -5 meters per second. These will go away. And I'm gonna switch these two questions. Some of the messages over, that doesn't work anymore. Guess we'll clear this. I've reached the end. There we go. Okay, so again, time, seconds. I go 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. My velocity in meters per second. I started out at 30. And that negative sign is still there. By the way, 30 meters per second is a little over 60 miles an hour. What will me up by, after 1 second, what is my velocity?
25,
Then
20,
keep going.
15, 10, 5, 0, -5, -10, -15, -20.
All right. So the answer to the first question, what is my final velocity, or what is the final velocity?
-20 meters per second.
Yes. All right. Questions on how we got to -20?